Manish ji, are you there?
Yeah, I'm here. Can you hear me?
Okay. Yes, yes, please.
Can you
We can
hear this
start.
sound, video sound? Can you hear this sound, video sound of this video?
Yes,
Yes,
yes, yes,
yes, yes,
please.
yes. But some problem.
ये लो खाना।
अरे चाची, इतना सारा खाना, पर आपके हाथ का अचार गायब।
धूप निकलेगी तभी तो अचार तैयार होगा। भगवान जाने इस मौसम का, बार बार छत पे भागते रहो, एक यही काम रह गया है मेरा।
आपके घुटने कैसे हैं चाची?
अगर ऐसा मौसम रहा ना तो एक दिन ये भी खत्म हो जाएंगे।
मेरे पास एक इलाज है चाची, ये देखो।
फोन पे?
हाँ, धूप कब निकलेगी मतलब आम कब सुखाने हैं, सर्दी कब पड़ेगी मतलब घुटने कब बचाने हैं, ये सब आपके फोन पे।
ये सब तुम्हें कैसे पता है?
मेरी कंपनी है ना, उसका ऐप है ये। मौसम से हम सबको फर्क पड़ता है चाची। पता हो मौसम कब बदलेगा तो हम कई चीजों की तैयारी कर सकते हैं, आपके अचार की भी।
अरे वाह, तू तो कमाल का वेदरमैन निकला।
Weather is a hidden layer of insight that can predict how we feel and the decisions we make, the foods we crave, and how and where we satisfy our appetite. We drink more fizzy drinks when it rains and eat more yogurt when it's windy. Indoor paint sales increase when there is above the average wind. Hand and body lotion sales increase when there is no cloud coverage. Auto gas sales spike when temperatures are colder than average. Arthritis and COPD can increase on specific days. You can get an advance.
Hi everyone. Thanks for giving me chance to talk here. Um, uh, all my colleagues, PhD time colleagues like Jagbandhu, Ashish, Hashima, and Madhu and others, my industry friends like Surya and all other respected scientists. Thanks for joining the talk. This video I shown, first of all, to show that I can act also. But the another thing was that whether we all are from weather community and we all know that weather impacts in our day-to-day life, knowingly or unknowingly, we make our decision based on weather. This video was shot when I was in my previous assignment in IBM, and just wanted to show that this weather, if weather forecast is accurate in time, it helps to make many business decisions, and that's how the industry is growing and business is growing. So with that, would like to start my discussion today. Today's discussion, I would like to start with first to show what is accelerated computing. Then I would like to talk about weather and climate models, how they are performing well or they are more utilized using accelerated computing. Then would like to talk about our NVIDIA's AI-driven forecast model, which is called FourCastNet, some studies, some results, and then in end, I would like to briefly touch about quantum computing, which is emerging area, and how things are progressing in quantum computing. It is at its infancy, but would like to just touch upon how it is going. And all these points I will briefly touch today. The objective is to just to introduce here what is happening, how it is going. Then later on, if anyone would like to have further collaborations or we would like to jointly do the problem and all, we are more welcome to have detailed discussions. So with that, let me start with what is accelerated computing. Before that, few weeks back, our CEO, Jensen, he came, visited India, met Prime Minister, and then you might have seen many announcements in the media where people are investing now towards Gen AI or Indian cloud. Even today, Times of India has a big article on these. So the world is trending where the GPUs are being used in every domain or every aspect in our life. Few applications I'm showing here, but you will see indirectly, directly, the GPUs are being used in all the domain. The latest trend is about ChatGPT. You might have seen, heard about ChatGPT, might have used that. That also run on GPUs. And then we come to now the Gen AI time is for Gen AI, where also the processing power required, too much processing power required, and to have in-time solution, we need the accelerated computing for that, right? With that, I'm not going deeper what is the use case in each domain, because today we are more towards weather side. So let's start with that. But then first thing comes is why we need the accelerated computing or GPU computing, right? And how it came up to how it reached the current status, current stage. And by the way, at least I'm very sure the IITM and NCMRWF, they do have GPU access machines there. So whatever today I'm demonstrating or discussing, everything can be replicated on your systems, and your future systems will have large number of GPUs. So you can plan your activities on that, right? So earlier, what used to happen is around 1990 timeframe, we used to have every year CPU frequency used to increase, CPU perform, and that used to increase the performance of the applications. Generally, that was going on with the 1.5x per year, right? That was well in according to following the Moore's law. So every 2 years, the transistor gets double and the speed gets accordingly double every 3 years, and that was going on. But around 2005 time frame, everyone felt that there is a constraint with the energy requirement. If we increase the frequency, the energy required is more for the processing, and then the chip size and other constraint came into picture. Hence, the performance start increasing by almost constant or 1.1x per year. So that's where we see the throughput or performance gain after 2005-7 with CPU runs. It is almost constant, and that is not increasing. In 1993, NVIDIA was established. Earlier, we were known as a graphics card company. Around 2005, we came up with the CUDA. That is the layer which software layer which allows us to exploit the graphics card processing power for number crunching. And that's where the scientific computing start running on the GPUs. And how it works is only few, like right side, if you see the any application which has a code, green color portion only gets offloaded on GPU, remaining all remains on CPU. So we are not replacing CPU. We work as a co-processor with CPU. The part of the applications get offloaded on GPU, and that makes the performance enhancement significantly in the application. And with that, we are seeing now year to year, we are increasing the performance of all the applications, and the gap between CPU only code performance and GPU enabled code is increasing significantly. It is going up to 2,500 times performance gain almost. In next couple of years, we will be that much huge gap with CPU only and GPU enabled computing. The another advantage with GPU, if you see that green computing side, it's an energy saving as well. So that's where the things are enabling with these codes, right? With accelerated computing. One of the example how accelerated computing, this is not from weather, but this is the COVID time it is being used. Hence, I thought just share here. So with accelerated computing, if we make any code enable on GPU, then there we get the performance gain. Then we came out, NVIDIA acquired InfiniBand, Mellanox, which has their InfiniBand interconnect. So that's where we get further performance, and we could go multi-node, multi-GPU performance. And then further, it is enhancing now when we mix HPC plus AI. And that's where we are seeing the trend, or fusion is the trend now, where the performance is increasing significantly. One of the example, right side, it's an MD code, and this code is being used for drug discovery during COVID time. So if we see the bottom side, the blue line, bottom blue line, that is the performance from CPU only code, where we can have 10 raised to the power 6 atoms per nanosecond. That is the unit for measurement of MD. Very popular code. Then we go further, we make it GPU enable. We went up to 10 raised to the power 9. Then we make it multi-node, multi-GPU. Then we went up to 10 raised to the power 12, right? Those atoms per nanosecond. We made significant gain in terms of CPU. CPU only was 10 raised to power 6, whereas we with GPU we reached up to 10 raised to power 12. But there is a significant gain pickup when we fuse HPC plus AI together, and that's where we got 10 raised to power 18 nanosecond per day. So atoms nanoseconds, right? So that was the significant gain, and based on that, the computation during COVID time made on name using NAMD made on this using accelerated computing, right? So the future is HPC plus AI. That's a fusion is going on, and then we are augmenting the HPC using AI, right? How to applications, how they get accelerated? There are three ways. One is we replace the existing library like your FFT, LAPAC, and BLAS in your code with the GPU-enabled libraries. That gives you the significant speed up, like cuFFT, cuBLAS, and so on. Then, if not, then we use the OpenACC directives, like you use OpenMP pragmas. Similarly, OpenACC directives can be used, which tells compiler that this particular portion of the code has to be offloaded on GPU. And with those directives, we get significant speed up. Then the last but not least, we support the CUDA. CUDA supports all the languages, Fortran, Python, C, C++, and so on. One can write the code using those languages, which gives the maximum flexibility, how much resources on GPU should be used, how they will be used. So these are the key three ways to make your code accelerated, right? In general, before starting for that, one should look there. Most of the majority of the application, around 3,000 to 5,000 applications, they are already enabled on GPU in various domains. So whatever application you are working, just try to get an idea. It might have already been ported on GPU, but if that is an in-house code, then certainly that might not be ported. We can work on that, right? This slide, just to give why how NVIDIA is now leading the application space, or how we can get the maximum speed up with those applications, because now NVIDIA is an end-to-end company. Now we are not only restricted to GPU. We are coming up with our CPU, which is ARM-based CPU. We have data processing unit. Based on that, we have various solutions. These are bottom line is hardware solutions. We call it our system DGX, HGX, and so on. Then we have acceleration library, as I said, cuFFT, cuQuantum, and so on, depending on the domain, cuDNN, TensorRT, and so on. So these are depending on the domain, there are various libraries. Above that, we made a frameworks, various frameworks like Modulus, like Riva, like these are top is the frameworks where application developer need to work on these frameworks. No need to bother of underlying architecture, what it is. So now the beauty is on application developers should think about their application, their algorithm, and so on. No need to bother about bottom architecture, whether it's a V100, A100 GPUs, or whether it's a on what kind of CPU is there, what's the performance, so on. So these are easily ported, and these all frameworks are available, and one can use on all. Even if you have V100 system or A100 system, you can try all these frameworks. These frameworks have different uses according to their applications. Like NeMo is for our large language model, and there we are using now LLM side. Magazine is in meeting. Suppose you are talking in Chinese, Japanese, one needs the translation that Magazine does, online translation. Modulus is the framework which I would like to cover today, where in general all AI models, they get the training, the data, and then we do inferencing, right? But while training the data, we do not follow the governing equations, which is key for weather forecast and few scientific domains. So there the modulus come into picture, which takes care of all the governing equations, and I will cover that. But there are around 300 frameworks available like this, what I am showing the top layer. So anyone working in any domain, one can try to exploit these frameworks and start working on that. Another angle into it is all these applications are available now in container form also. So one can download the container, get the binary and environment, directly run the applications. No need to bother of compiling the application, dependent library, versions, and so on. So that's where we are making quick turnaround for applications guide, no need to bother architecture, and around the ecosystem like compiler, OS version, math library, and so on. Just download the container, get the binary, run with your input, and get the output, and work on the analyzing the output and understanding the output, right? The future trend is going, as I said, now HPC is evolved. AI, we all know now AI is personalized now. If we search anything on Google, next time all ads are coming to us. That is becoming personalized up to that stage. Similarly, medical diagnostic and other things are coming into picture. The future is going to the fusion of AI and scientific computing. That's where we are heading, and all new research and all you will see in that direction, right? So that is the background of accelerated computing. Now, quickly, I would like to jump to the today's main topic is towards the weather or earth science, right? Um, First, I would like to cover a few HPC applications, and then I would like to go towards AI side, right? So HPC applications, we are working on all three domains: climate, weather, and ocean. Uh, there are codes here, the list of the codes which are GPU enabled, and they are, or the work is in progress. Same like if you see ECMWF, IFS, that is also GPU enabled. The which NCMRWF significantly working. The next version of Gango or Lefric, the name. When earlier I was in UK, I was working on that, but now that also will have GPU enabled version, right? The icon model, Swiss Computational Center, they announced their next generation system, which will be available 2024 first quarter. There it will be on NVIDIA based system, and 250 petaflop system they are announcing. Already, if you can search, you will find that on net. There's too much details available, but they will use this icon model mainly, and there the uses are more towards weather. So I'm sure you all are more aware than me about that. The MPass model, NCAR MPass model, which is being used by IBM, and this is run on GPU. Therefore, they can run every hour model, every hourly forecast. They can every hour they can update their forecast using this MPass, which they say graph. IBM call it as a graph, GRAF. Every hour they could run. They run across the globe with 3 kilometer resolution. So you can compare here what we run in India on an average 10 kilometer resolution and 4 times in a day. But this graph runs 3 kilometer resolution across the globe. And that is, they could do quick turnaround because it is GPU enabled. And that's where they do further interpolation, and they are providing the forecast at 50-meter resolution, right? So that's the beauty of these accelerated computing, or when the code get accelerated on GPU, we can work on resolution, we can have quick turnaround time and so on. This is for WRF, which is well-known and commonly used model. So WRF is also accelerated on GPU, but it is now it's a licensed version available. The normal WRF is free to use, but the GPU enabled version of WRF is maintained by Acecast. That company maintains it. I run that model, and it's giving you the rough idea what's the performance gain when we use the GPU enabled model. The domain was given by Amit Kesarkar, Dr. Amit Kesarkar from NARL. So it has 93.5 million grid points, and on this is triple nested, and innermost domain was around India. That I run the same model I run. So this I'm showing the average time step performance, one time step. So if we take CPU node, the performance, the average time step was 10.2 seconds. And same with go with the GPU nodes, up to 40 GPU, we get around 46x performance gain with that, right? So that is something, the ballpark figure I wanted to convey about that. And more details available on the paper. You can search on IEEE Explore. That paper is available. So with that, let's move towards AI. First, what's the need of AI? This slide you all know better than me, but generally we divide the NWP in 4 stages: data assimilation, then dynamics, then physics, and then we need a time that we need to make a forecast that should be in time and usable, right? These are the 4 key pillars for NWP, right? And then there are challenges. First, one thing we all know that if garbage in, then garbage out. If our input is not correct, then we can't expect that right output, right? Sometimes we do not, or many times we do not have observations. Those are incomplete because sometimes they take time to reach. Before that, we need to start the model run, or sometimes they do not come, right? And then time, sometimes the observations are late, so we do not have enough gap between observation and to make a forecast, right? There is no gap enough, and there we need more compute power in that to make quick runs. But sometimes the model has limitations that even if you add more compute power, it can't make a forecast sooner than some limitations are there, right? Then we have not we can't ask too much compute power at every time, right? There is also a limitations on that. So these are the key challenges what I try to capture here. These are mainly for NWP side and HPC side, right? So to leverage to solve that, everyone started working on AI. That let's use AI, which is artificial intelligence, to address these shortcomings one by one, right? Generally, NWP, and if we see start to end, there are these 6 stages I am showing in the right side. We do the data collection, then quality check or thinning, then we do assimilations, then dynamics, then parameterization, and finally we make a forecast, right? In all 6 stages, we can use AI, and I'm sure we all are using AI, knowingly, unknowingly. But the AI can be used in all these 6 stages, and we can augment our HPC runs with AI. Right? How the AI being evolved? Earlier, if you recall, we used to write a Fortran code, and then we used to instruct our compute machines or computer that we do certain kind of computation. Same you should do with the different data set. That is also kind of, we say we are making system expert. That is kind of artificial intelligence that it does the computation. So that was the era of up to 1980 that was going on. Then the email came into picture, and if you recall that during email, if we set a rule that these kind of email just put into the spam folder or in a particular folder and all. So once the machine learns that how you are doing, similar trend they follow, right? That we call it as a machine learning. These are the broad definitions. And now deep learning, it learns everything from the data. That is the era right now we are, and now the next is Gen AI and so on going on. But mainly we are in deep learning era where everything learns by data, and then we try to forecast inference based on that learning, right? Based on that training. So that's where we are. In weather side particularly, where these AI or MLDL can be used, I divide into these 6 categories. We can use image detection, that is for cyclone detection, or tropical cyclone, rivers, or how rivers are changing path and so on. We can do that. Translations, we all do. We all know that from normal domain, if we do the computation in FFT domain, and that is much faster, much smoother, and then we do the inverse transform, right? So these translation, those are also can be done through AI much better way and quickly, right? Then sometimes we make ensemble because to avoid the uncertainty around our forecast, those also could be based on AI. We can define the weights, which forecast is good, and around that we can work on that, and that's how the AI can come into picture here. Sometimes we do not have observations, and as I mentioned before, the missing of observations, or we need to repair a particular frame, there also AI can come into picture. The emulation is nothing but what you say, that if we know that particular kind of computations are being done repeatedly, then we can keep in crude language, we can keep a table ready. And then when the particular kind of scenario comes, just pick the final outcome from that table. So we save the computation time from there, and that's how it helps our forecast better. And then parameterization, sometimes we do not have physics for at a particular scale. That time we can use the database parameterization, and that gives better accuracy to our forecast. I would like to consider few examples quickly about where these work has been done and where some paper has been published. So first of all, this acceleration via emulation. So this is, as I said, that we know that at a particular scenario, we need to do some computations, and that takes significant time while do the computation. That we can keep a table ready, a smooth curve we can keep ready, fast surrogate model kind of, this is what we are showing. So we can keep all scenarios ready in a particular format, and when the computation come, it just pick up the value from there. So this is the E3SM super parameterization from shortwave and long wave radiations. Here we keep the same thing, emulation for these, and we get around 10x speed up, right? This is from ORNL. This is study published there. So one can get more detail on the published paper, but this is for parameterization, this become much faster for that, right? Next one I would like to show is this is again data-driven parameterization. And here, if you see the right side, there are three columns we are showing. The first one is for high resolution. Second one is for lower resolution. Both are not able to capture the actual scenario, right? The last one is for random forest, using random forest, and that is able to capture the better scenario for precipitable water, right? So here it helps this AI-based parameterization, and that gives more accuracy. Again, this is a paper published in Nature. One can look into that. That is available online. This is again IFS forecast temperature. This work is going on. This is started in 2020, and still the work is in progress. Here we try to improve the data assimilation using the AI techniques. If you see right side bottom graphs, here we are showing three comparison with the three different techniques for 4D war, 4D war operational, and the top one is the 4D war new. If you see, new is showing the consistent performance with the 4D war operational. And as we go towards even forecast day 9 or 10, still it is showing good performance, comparable performance. More studies in progress with that. This is for bias correction, common use case across all our forecast, right? Where we use AI for bias correction. Now the for ENSO modeling or different kind of what we say the feature around Earth, we have radiation and other phenomena around Earth. For that, we use this deep learning based multi-year ENSO forecast. Here we show the various forecasts from various models, how they predict and their skills. You see the majority of the forecast models, their skills lies up to 12 months and so on. Only two models, one is CNN based and another one is the syntax model. Both are showing up to 24 months, 23 months here or 24 months. There, the CNN based model is showing even in between the error skill is higher, and then later on also it is comparable. So the good skill score we are getting using CNN method. So there is a significant work going on in this direction as well. Recently, if you see the live example, one would like to see that you all might be knowing that Pangu weather is available on ECMWF webpage. They are making what you say live forecast based on the deep learning based model on ECMWF page. So things are progress now where they get the input data from HPC model and then they do further forecasting using deep learning model or machine learning model to make a in-time forecast and make more useful forecast, right? So these are augmenting each other. This is for another paper. This is again from Nature. Um, there we are showing that if the data are missing, how to reconstruct and how it is useful to make a better forecast even in the climate information, climate scale, right? So these are the various stages we are showing that what is the input for AI, then output composition, and then further how it improved with AI, right? This also paper published. One can get more details with the paper. Right? I'm not going more detail into those. Just wanted to give an overview, and then we can have further discussion whenever we are looking for. The one slide which I wanted to touch is the use of AI. One can argue that we are doing the HPC-based weather forecast, and it is impacting life. People are able to make decisions, so that is good. Why we go to AI and all? It's not only to save the computational power. If we see the use case there also, we need quick turnaround time. Like wildfire. Wildfire can ignite and then it can propagate in any direction. To have those simulation quickly, that anything may change in the forest once we get wind direction and other things may change. So once we get observation, we need to have quick turnaround time. So there, these AI-based models are useful where you have your HPC-based model. They give you the concrete outputs, few variables and all, but then we need every half an hour turnaround model forecast and how it is changing. That time we can use this AI model, which are quick to run, and then they are based on HPC, right? Same with the insurance, same with disaster management and renewable energy. All these are need quick turnaround and quick model, right? This is one of the paper I publish here with my intern, Adrian. So here what we did is we use this for temperature forecast, which you all may argue that forecasting temperature is easy. Here we use, but here we use the data from the renewable energy company. And then we try to forecast based on their requirement that what time they need and how it helps them in to make decision to buy energy. Right? So here we use two methods, LSTM and random forecast regressor, and compare those performance for, I think we done it for around 20 locations in UP, and that we compare with the observation, and this was found to be useful for their decisions also. Business decision also, this was useful. Right. So with that, now I would like to go more towards deep learning now. So before going to that, as I shown before, that NVIDIA Modulus is the framework which is based on physics-informed neural network, and this follow the governing equations, right? What is the key for our weather model to follow all the governing equations? So that's where for scientific computing, be it in weather, be it in CFD, various industry, all are using this Modulus framework, right? So based on that, NVIDIA came up with our own deep learning based model, which is known as adaptive Fourier network operator. Based on that, AFNO, we call it as a FourCastNet. This is the neural network architecture, and this model is already trained for ERA5 data, last 40 years data. It is already trained. The resolution is approximately 0.25 degree. Here we have 20 variables, all commonly used variables. I will go to model, run the model now, and then we train it on 64A100. Now, when we do inferencing on this, it takes hardly 3 seconds. And this is open source model. One can use it easily, and one can start to research based on that. The bottom is the link for that model. I would like to go now to that model to show that how it is helping, how we can run and how what is there. I hope you can see my screen. Someone should confirm.
Yes, yes.
Good. So this is that bottom link where you will get the model, right? I'm not running now. I just run morning because running may take little time, but one can simply run here. Just put the control enter. This is a Jupyter notebook. All you might be aware. this can be run. So this model is ready to run. We have all the libraries. We need to download the data. This is the steps to download the model, and then we have the data. So the data can be downloaded using this step. Then one can look into the data. What are those? These are the steps to set the path of the model, various paths, how it will get those. Then we can, these are the key variables what are available. You get UV, temperature, surface pressure, then mean sea level pressure, then TCWL, then again UVTW and so on, right? These are the key variables information you will get, relative humidity and so on. Then we would like to visualize those data. So here is the observations, how they look like. Then further, if we go down in the same this thing, then we start loading the model, and the detail of the models are given here. This is adaptive Fourier neural network operator, how it works. That flowchart is also mentioned here, how we apply FFT and inverse FFT and so on. And so all details are here, one can go through. Then based on that, we make some forecast here and we compare the forecast. So I come directly to that. To compare the forecast, we define two errors in this book, notebook. One is RMSC and another one is anomaly correction coefficient, ACC. Both are, we compare the skills of the this model based on these two parameters, right? RMSC and this ACC. So now we start model, and we see that few results. You see that every time step how the RMSE is increasing, that we are showing here, RMSE and ACC. Then further we go down, then this we are showing the quantitative forecast, how it looks like, the ACC and RMSE, how much they are increasing. So RMSE goes up to 3.5 for 120-hour forecast, so which is reasonable, I believe. And all these forecasts are in 2-3 seconds you can get it. That much the time we are getting. And these are the precipitation FourCastNet prediction, and then these are the ERA5 ground truth. Both are compared here. Both are plotted and compared here. The one more thing I would like to show, the use of these for hurricane tracking, or we can use it for our cyclone also. So I'm just showing for hurricane how the track look like. So if you see the truth is blue line, FourCastNet is red, one can compare these track and these are comparable, right? So with this notebook, where my summation is, if we can start using for India data, first someone should use the ERA5 trained data only, and then take the output for India data and compare it with observed, make some cases, and then further we can use it training with India data, and then we can make an Indian based model also like that. That is one step. And second, we start using these AI, this FourCastNet model for our client in renewable energy or other side to make better forecasts as per their requirement. They may have the different domain, high resolution domain, or they need quick turnaround time. Like renewable energy guys, they need the forecast for every 15 minutes for next 24 hours. That's because they do the trading based on that. So those kind of things can be addressed using these models. So these are ready to use. I submit everyone here. Try these model once and have an experience, and then start taking advantage in your day-to-day research on this model. Right? Here it's a very clearly written what is even the limitations of our model, and like one is it's a ERA5 data. Then the resolution is approximately 25 kilometer, as I said, 0.25 degree. So that is still we feel coarse, but with this coarse resolution, we are getting good accuracy as I shown above, right? We are going further down. We are going for higher resolution. Soon we may have newer version with the 12 kilometer resolution coming in a couple of months. So one can start working and get comfortable, and the new version is coming there, right? So with that, this is all about the deep learning model, which is freely available. I would like to share this in the chat box, the link that may help. So then I will take the questions, but just let me touch base some time base. This is also emerging area about quantum computing. I will be real quick in this quantum computing side because it's an emerging area. But anyone who is interested to start research on that, or I'm sure few scientists are already engaged in this domain. This is the upcoming area where we will converge AI with quantum. The QML, quantum machine learning, is the area where everyone is looking for. It's at infancy. Uh, in every domain, the quantum computing is still in not, I mean, emerging day to day. You will hear the new announcement every week. You can hear the new announcement, but it's emerging. It is becoming a reality that quantum computing will be there, and there will be new research coming up. So anyone would like to invest time in this, this is the time to enter, and then soon one can lead, right? And the quantum computing based on the principle of quantum mechanics, where the duality is there. The particle or the smallest particle can behave in two ways, either in the particle or wave progression, right? So based on those, there are key features. If you might have heard, these are the common terminology used in the quantum computing. One is in classical computing, we have bits. Those are represented either, those have values either 0 or 1, right? Where are the in the qubits, we can have both the values together, 0 and 1 together, and based on their probability, the computation goes, but final output is always either 0 or 1. So that we call it superposition, that it can have two values at a time rather than bits having only one value at a time, right? Then the another key features for qubit is they are entangled. So suppose we have two bits, they always distinct from each other. One bit has having 0, another bit may have 0 or 1, but they are not related to each other. Whereas quantum computing, these qubits are related to each other. One qubit influence another qubit as well. So that we call it as an entanglement, right? So that is the key feature, that if two qubits are there, we can represent 4 scenarios together. Similarly, if we have n qubits, we can have 2 raised to power n states in one go. Whereas in bits, we can have the number of bits, and those many scenarios only we can represent. So that makes totally change in the dynamics and computations, that we can have many scenarios together in fewer qubits, and then that's where the computation may become faster with these features, and that's how things are progressing. I may not go in detail, but there are various things going on here and various kind of research going on. Even in India, there is significant work is going on. Government announced their national quantum missions that is going on, and various hardware research as well as ecosystem development, those are going on together now. Right? Where is the NVIDIA into that? Just one slide on that. We know right now the quantum computers are being developed, not matured yet. So right now, all the simulations which tomorrow will run on quantum computer, they run on classical computer only. And that's where what NVIDIA's approach is, the any system which is GPU enabled can be used for HPC, can be used for AI, and can be used for quantum simulations also. We have our framework, cuQuantum, where all the standard available quantum frameworks are integrated with that, and that cuQuantum gives the acceleration of those simulations. I will show you a few results there. The another thing is key step is CUDA Quantum. So CUDA Quantum is our framework, which allows today you develop your code for which is running on classical system or your available HP system. Tomorrow, same code can run on quantum computer. We are talking with the quantum computer and we are interacting with them. Future, how we are envisioning is HPC and quantum computer together will work. So part of the application will run on HPC, and fewer portion of that application will go on quantum computer. It will run there and come back, right? So the offloading from classical to quantum and taking back the results, that's where the CUDA quantum comes into picture, and it facilitates that offloading and vice versa. So cuQuantum and CUDA quantum are offering, which enables simulations on your existing system. So if anyone would like to do quantum computations or quantum computing research with your available system, you can start there with cuQuantum and CUDA quantum. They give you the framework. You can start there, and tomorrow, whenever quantum computer comes, you can directly run those things on there, right? This is my work. Recently, we worked on a CDAC system, which is 75th number in the top 500. There we shown that their standard algorithm like Shor, quantum Fourier transform, and Sycamore, they are commonly used kernels, I can say, because like FFT, QFT is there. There we shown that if we run QFT on CPU and then when we use the GPUs, how much performance gain. So this is more than 100 times performance gain when we use this. I would like to touch this QFT because any of your code which is using a FFT, you can start using that, replacing that with quantum Fourier transform and see how the performance is. And from there, you can start your research, right? Again, this I will skip, but there is a significant research going on, weather forecast and climate change. There are various companies engaging in this domain, like IBM, Pascal, Rigetti, 1QBit, and so on. I put here few only. They are working in this quantum domain and try to come up with some solution. But still, the weather forecast, it's in infancy. They're starting from basic steps. But two places where we see the quantum advantage. One is in a NWP model, we can have many variables depending on the spatial and temporal resolution. We can say around 1 billion variables where we would like to have output of those variables, right? On quantum computer, as I said, 2 raised to power n states we can represent together. Only 30 qubits required to represent these for 1 billion variables. And that makes our computation faster and so on. There are challenges still which people are trying to overcome. The Schrodinger equation is linear, which is the main key for quantum mechanics. But what we use, the Navier-Stokes equations, they are nonlinear. So still the work is in progress. I am noting down few papers here in bottom that gives rough idea how the weather and climate prediction going on. People are trying to make some research into that, but still it's at its infancy stage. Personally, I believe the one is this many variable scenario will go together. That's where quantum computing will show the advantage. Another one is the ensemble forecast, where again ensemble is nothing but we take various scenario and make a various kind of a spread of our forecast. That will also be very quick with quantum computer. So those are the two key areas right now I am seeing where the weather forecast related research is going on. But later on, how it is emerging, day by day, things are changing rapidly, right? So with that, I would like to close. I believe I am, top of the hour. So let me take my few questions and then, with that, I would like to conclude. So
Thank you, Dr. Manish.
So,
hello.
Yeah, I can hear you, Ashish. Yes.
Yeah.
Yes.
We have a few questions, 3 questions. I'll just read out, or you can read it from chat box.
I'm trying to read. I am trying to read.
Yeah.
So good morning, everyone. Please type your questions. It would be great. Slides. Okay, slides I will share. Then we are recording. Why not much improvement in the first few months? This is regarding ENSO forecast. As I said, that research is still going on. The result what I shown is last year's, but now I'm sure that further is improved. I will share more details on that. Right now I do not have, but current status, these are much improved now. Yeah. What is the promise of FourCastNet model? Premise of, so as I said, FourCastNet model, it is trained on 64 A100 GPUs But now for inferencing, it needs only one A100 and that takes only 3 seconds. So hope that gives an idea, Raghu. Are there HPC resource challenges for running FourCastNet model? As I said, this is training time is critical, so that takes more GPU. We train it with ERA5 data using 64 A100 GPUs, but we can try in India with a different kind of number of GPUs, and we can run that depending on the resolution and domain size and all those things, right? So that we can do. So it depends how we are designing our experiment and how we are doing. But rough idea, with 40 years data, 64 A100 GPUs are enough. And then for inferencing, we need 1 or 2 GPUs, not much. How can blockchain technology be associated with several computing in relation to climatology? Right now, I do not have answer for this, but I can come back on that. Right. Can you give more? Sorry, what is that?
Manish, I am Professor Keshipati from Mathematics Department.
Yes, sir, please.
We have started a new course on quantum computation actually. The
Okay.
MSc Mathematics, they have started one. And I am telling that there what is the physical applications will be all this pure mathematics and quantum computation. So students are very interested to actually learn this thing and practical applicability. So how
Sure.
can your organization help these students who are MSc final year student?
What kind of help you are looking, sir?
Sir, applicable. Suppose they learn the basics of quantum computation. Some of the up to algorithm they will learn. Then how to do some programming, how to apply this one in whether modeling or something like that one. Whether that can be done.
Sir, we are, as an NVIDIA, we are providing the infrastructure. We are providing the simulations and acceleration. I do have a talk tomorrow, Friday, again with the KL University, followed by in Delhi, some event is there. There also I am presenting, or I am a panelist there. So we can have a session for you whenever you are looking for. That we can do, enable you on this system. And these are across, as I said, any system which has A100 GPUs or minimum some firmware required. So sometimes it runs on V100 GPU. So there you can get these simulation environment. One can start working on that. That we can do, sir.
Okay, thank you.
Yeah.
Manish ji, actually, what he probably meant also, like suppose students learn all these things, what is the future? If they learn regarding quantum computing, whether there is a chance for them to get placed or something like that.
Yeah. So that's where I started with quantum, and then maybe sometime we should talk about generative AI and all. These are emerging areas, right? So let me say that how to say, what we worked, Jagbandhu, in our PhD time, or Ashish, when we worked that time, HPC was the domain, right? To how to run the multi-node runs and how to make that was the key that time. Now that is becoming, I mean, most of the guys are running that, and that is not that hot now. Hot is now the quantum, HPC QC integrations, and then the generative AI, quantum machine learning. These are the areas where industry is heading towards. So certainly when a student get exposure of these things using this FourCastNet model, Pangu weather, and there are 7-8 models, AI models available globally. A student get exposure to these models, deep learning techniques using those. Certainly the future is very bright. Their industry will be keen to have them on board. Is that the answer, Jagbandhu?
Hello, Manish, this is Srinivas from National Remote Sensing Center. Actually,
Yes.
is it possible to have access of your system to whatever that available as of now? Some of those GPU converted models are available for weather forecasting. Can we test?
So that's where I believe I'm trying to bring Ashish and others on board. Whatever system they have or IITM has, there these models can easily run, sir. I can take you to other places where these things are running and all. but we can talk offline how to get system access. Yeah, that's not a problem.
Yeah.
But ideally, anyway, yeah, anywhere the system has GPUs and all, one can run there.
Okay. As of now, we don't have that GPU and CPU converted systems. I will talk to you later.
Sure. There is another
Manish,
question.
yes, so that's it. That is what I wanted to say. There are some more questions, please.
So Surya, he's my industry friend. Can you give more use cases where FourCastNet can be used? More info on where all the FourierNet is used in the weather domain. So Surya, as I mentioned, I worked for the this African wildfire where we use this FourCastNet. We give them quick forecast on this using FourCastNet model. We are comparing it with the other models and how useful it is. Certainly, we are showing good skill with that, and it is helping them to make good decision. And for there, when using this FourCastNet is based on only weather parameters. Then we accounted for other parameters in the forest, like how many leaves are there any fuel nearby which can ignite the fire more, and those parameters we made a model about these FourCastNet, and then we made it useful information for them to take it up. Similarly, it can be used in the insurance sectors and other where insurance sector takes our wind footprint from weather models, and then they mix with the exposure, and then they make a final decision for the premiums of the insurance, right? So there are various use cases. I see this is the way to go forward, where we have first HPC run, get the input data, and then make final useful forecast using these deep learning based model. And that's where I believe if not now, in 1 or 2 years, you will see everywhere things are moving there. Already I'm seeing this is the trend. So, okay, I hope I answered that question. Next is Ayush. So for forecast fire, LSTM RF is used. No, there is a confusion. It is not being used. So therefore, forecast fire, we are using FourCastNet. LSTM RF I use myself with my intern to make a temperature forecast. There we took the input from IBM weather model as well as Met Office, India Met Office weather model, and we make the temperature forecast. And that's where we use this LSTM and RF both techniques, and we compared those skills, right? So forecast fire is deep learning based. Yes.
Manish, in this connection, I just want to ask actually for forest fire. So LSTM is the best model, or there are some other deep learning models like CONV, LSTM, those kind of things will be better.
See, again, I think we are mixing these two. So, sorry, I kept in same slide. Okay. For LSTM based approach, I myself use for temperature forecast, and that we use for renewable energy side. The other side, what we use is this thing, this deep learning based model for forecast fire. That's what we use so far. So that is the this thing, but we need to more evaluation for Indian conditions and what data we get and how the use case goes. So that's where the things are. Good to see you, Raghu, after a really long time.
Okay.
Yeah. I think I answered the questions. Yeah.
So there is one more question. How can accelerated and quantum computing could be more available and accessible to students in all institutes at all levels?
Oh, okay, yeah, that is the question. Second, so what NVIDIA approach, and that's where we are heading, is in your existing system you can do all quantum simulations, quantum computing you can do. It's not only single node, you can go multi-node for large simulation. In real time, the number of qubits required, generally that is the unit right now being used, that any system, how many qubit it can simulate, right? So, and those qubit has to be error free and so on. So with the NVIDIA framework on your GPU enabled system, you can go up to 1000 qubits and so on multi-node. So that's where I'm saying if you have any system access which is GPU enabled, you can easily get this framework and start your research. That is the key, and that's where we are heading to make it easy for everyone to use at the moment. And same code today you try here, same code will run when actual quantum computer will come. So no need to change anything.
Okay, so the another question is using the GPU based forecasting, is there any chance of data loss or information which could not be fetched from the input provided?
No, I do not see that. GPU is the co-processor. It makes the processing faster. So whatever instruction we give, it works on that. So there's no loss of information and nothing like that.
So there is one more question. Please demonstrate, sir, how far this forecast model predict the extreme rainfall events over India.
This study needs to be done. I invite you, we should work together. So this is the model is there. We make forecast up to 120 hours, but for Indian conditions and all, we need to work more on that. Yeah, not being tested yet. Yeah.
I think Raghu sir is interested to ask some more questions.
Yeah.
So we are not able to hear you.
He got disconnected or something.
The internet
Screen frozen. Video is a problem.
Okay. In the meantime, any other?
Can I ask one simple doubt? Many people have a doubt. AI is replacing the HPC. This is the major doubt of the community. The AI is replacing the HPC. Is it true, or maybe clarify that?
AI is augmenting the HPC.
Okay.
And if you see our needs now, we need quick turnaround. See the practical need. Come to the practical need, then we will come to solution. We need quick turnaround time. We need okay, things changes. What will be the next half an hour weather would be? Accordingly, I need to make my arrangement. Energy side, they purchase the energy 24 hours before they go to the exchange and they buy the energy. And there they change every 15 minutes and they need only two parameters, temperature and humidity. So there they need quick turnaround time. Now 15-minute forecast for 120 hours or for 24 hours, our NWP may not give that. So that's where AI-based forecast based on HPC output is the way going forward. So don't think that we are replacing HPC. HPC will be there. AI is making useful stuff for user community. That's where we are heading. So please remove that.
Basically, he's saying that AI is going to help HPC to improve the performance of weather models or climate models.
AI is going to help users to use the forecast in better way.
Yeah, that's it. Okay, Raghu sir.
Please.
Yeah, there was some network issue. I have just two questions. One is about whether we have any examples, actual examples of.
Raghu sir, please turn off your screen. That may help. Looks like net is an issue.
You can turn off your video, please.
Yeah, now it's better.
Now it's better. Yeah, just like you use the word drug discovery, I want to know if there are any AI ML based examples where we can actually diagnose the forecast errors, cause and effect relationships and things like that. That is my first question. And if they are applied to weather and climate or any other such examples, purely applying it to diagnose. And next, my question is more general, like we have in science fiction and all, we come across where AI techniques are used, AI ML is used to predict the crime from happening and things like that. Is there any element of truth, or it is purely still science fiction? And if there is some possibility, like can we predict the future disasters from happening?
So first question, diagnose means you would like to compare the skills of the forecast or in weather particularly?
No, not yeah, in weather in particular and any other in general. Diagnose in this is the type of causal mechanisms that we try to understand. See, presently causal mechanisms are still speculative in the sense we start with correlations and then try to build physical models, isn't it? So,
Right.
but still, like they're all type of quasi type of this thing. They are not fully explained, many of these processes. So I was just trying to know if AI ML can help further because it can handle more higher dimensions. Is there
Yes.
any example where attempts have been made to establish cause and effect relationships?
They are there, sir, like these parameterization and all what I shown in my papers. Same like that way, there are attempts are being made to understand the data behavior for a given scenario. What I will do, I will try to collect all those paper and will share with you. I do not
Yeah,
have more. Whatever
sure.
I present, I have those info, but more than that, I need to collect, sir.
Sure,
I
sure.
will compare.
That will be very interesting. Yeah.
Sorry,
The
just to
second
jump in
one.
actually. Yeah, this is the other Raghavendra from NCMRWF. Just to jump in actually regarding your parameterization thing, there has been something called a cellular automata, which has been around for quite some time, based on actually like a game of life. Actually, like it was a game. So that is there actually that can actually be used actually, and it has been demonstrated actually for certain convective scale phenomena. So there are certain actually like simple parameterizations which are actually can be done through this, and they sort of also talk a bit about the causal relationship. So thought I would actually just put in a couple of my thoughts actually on this for this discussion.
No, thank you. Thank you. Yeah, sure. That's a good info. Thank you, sir. So I
The
will.
second question.
Yeah, you were saying the crime from happening or behavior of the human beings, right? I would take it in that direction. There is very much on these things. I visited Malaysia in 2018. The government invited me to know um, in railway station if some person is coming, they would like to know the what you say the expression of the person through images. So I thought, what you would like to detect? Is it the person is a threat for others and all? But no, it's the other way around. If person is not feeling happy or he is afraid or he needs something, if we can detect those, then we can directly provide help to him. So that time they were discussing those projects. So certainly these things are happening. Mostly it goes under the what you say image detection or diagnosis of the image, and through that it is going. But patterns or human nature, how to predict that is still, I think, going on. It's still not matured yet. So what you said that crime for happening from human. So their thought process simulation is still that research is ongoing. But through image, facial behavior, one can detect whether how he is feeling. He's angry or going to attack someone, or that is, yeah. That is there, sir. Yeah.
Okay.
Thank you.
Manish, there is probably one question from Indira Rani, Dr. Indira Rani from NCMRWF. Indira,
Yeah,
madam,
yes.
are you there? Yeah, please.
Yeah, I am here. Actually, there are many operational centers and researchers. They are using AML technique for forecasting and verification. But as per your experience, is there any method to do the data simulation? Because as of our knowledge, that we have not yet seen that people are widely using the ML technique in data simulation. So until right now also we are using either variational method or ensemble methods. But as per in your experience, is there any particular method that we can replace the variational method and ensemble methods?
I won't recommend particular method because in my PhD time we learned that every geography is different and data are different. But there are work is going on in data assimilation, significant work. One or two paper I shown in this presentation also. I will get more info on that and then we'll come back to you. But I won't recommend any particular scheme for particular scenario. That I can't recommend.
Because if you see that we are dealing with different types of data, and basically ML is data driven, and how much data we have to feed, all those things. I know that ECMWF, they are doing some thing based on ML technique, but it is not yet operational. But
that is operational ECMWF. Pango is
no, that is not their operational thing. It is only for that forecast part. Otherwise, in the IFS, they are not using any ML technique for data simulation. Yeah, that is their
okay.
Pango weather is only that basically for testing the ML methods in forecast. But I think I don't remember that is there any data simulation module in that. I don't think so.
No, in IFS they do some AI techniques. I will come back on that. We work
IFS for atmospheric and I think coupled system they are not doing, but land data simulation they are doing something. That is only the single level part.
I see. I will go deeper and come back, but they are doing something. That's what it is.
Okay, thank you.
Yeah.
Just before, I think Madhu Joshi madam wanted to ask some questions. Madhu Joshi madam, are you there? You want to ask some questions?
Hi, Madhu.
Hi.
Good to see you.
Thank you. Yeah, thank you for the nice presentation, and thank you NCMRWF and Jagbandhu for organizing this and sharing the link. I have just quick question. You have talked a lot of for this Q&A and then this ML and AI. Is there anything you're working on ocean and particularly the coastal areas?
Good question. So ocean side, we are working, but there are few models only we are working right now. But with the AI side, we are trying to address that. That is very at infancy. I can't disclose more on that, but work is started on that because now everywhere AI is being applied. How I should say, weather communities little slow than other community they catch up. Like you see this Chat GPT and other thing. Language side, the AI is more useful now, generative AI and all. Weather side, things are catching up now. So
okay.
So yeah.
Okay. Thank you. Yeah. Thank you. I saw in your couple of slides the I think the waves were propagating, and then I thought maybe something is going in back end.
Yeah, that is going on. As I said, the ocean side going on, but first people would like to have land side more. That impacts more, so that is more research there. But yeah, ocean side catching up. In few months you will hear more. Yeah.
Okay. Yeah. Thank you.
Thank you. Yeah.
Okay, Manish, there are a couple of more questions in the chat. First one is like, FourCastNet is data driven or physics based model?
No, so far it is data driven. We are incorporating now more physics into it. Yes.
Okay. So next question is, what scope for international students in this matter? Can it be used for doctoral or research studies in other countries? Someone is asking.
Where is that question? That's an interesting question. This FourCastNet is a global model trained on ERA5 data. Anyone can use for their area of interest. From there, one can start. And we are keeping it open source, so you can use for your convenience. And we are coming up more. You will hear more in next. Right now, beta version already there, where we made a framework where one can compare all the AI models and their skills. And slowly you will see digital twin. You might have heard the Earth digital twin, which we are making. So that will able to simulate all the climate scenarios live on this. So those kind of research are going on. I did not cover that because this is the first talk and I just briefly covered. But digital twin, digital Earth twin, then the framework based on this, compare the skills of all AI models, this thing, everything available, going to be available on cloud. Those kind of research are going on in NVIDIA. You will keep hearing these announcements soon now. We are focused more on this earth science domain. Yeah.
Okay. So next question is, what is the temporal resolution of FourCastNet model?
Right now we have 1 hour, if I'm right. I need to double check. But yeah, that is around hourly. Yes.
So there is a very long question. One
Can
guy
we
has
make the
written,
system
can
with
we?
AI and
Yes,
quantum computing? That is from Lokesh. To build a OS operating system like Mac, which is easy for scientists to in comparison to Fortran and MATLAB, because Fortran MATLAB are all so tough. यार ऐसा मत बोलो हमारी PhD इसी पे है.
exactly.
It will lead to main thing that scientists don't need to put a lot of efforts. And so right now, why
Manishji,
to
this before you answer, let me tell you, this guy, MSc guy, I believe our Lokesh, first year MSc atmospheric science guy. So probably he doesn't know much about this Fortran and MATLAB. He's starting to learn. So
No, that's
why
okay.
he has-
That's okay. But let's come to the operating system side. Why to make operating system? What we are saying are our CUDA quantum, that is the framework. Right now, it will run on existing system HPC. Tomorrow, whenever quantum computer will come, that will work with the HPC system. It will attach to the HPC system. And that CUDA quantum will take care of everything, offloading the data to quantum computer, take it back and everything. So just simply right now, write your code using Python, C, Photon, whatever you feel, using CUDA quantum framework, and life will be easy.
Okay. Someone has asked you to
Share the
send
paper.
paper.
Okay, I will share the paper. No worries. Okay. Sushant is also from your institute or where he is?
I don't know which Sushant it is. Maybe.
Sure, no worries. I see my industry friend also, Rudraksh and others are joined, so that's okay. Okay.
Okay, so is there any question, other question from the audience?
I think no.
Okay,
Thanks
fine.
to Dr. Manish, a nice presentation and informative on the AI, ML and DL. So thanks. We hope we'll work with you in future in collaboration with your NVIDIA and NCMRWF. If you have a chance, we can get talk with you about the this forecast model, AI model.
So I would like to have Ashish as I shared today. My objective was I shared the model. Let few people try that model. Yeah. Let's have few deeper insight rather than introductory talk. We should go deeper, and then we should have deeper engagement. And hence, I shared this link also to everyone in the chat. One should try that, make with their input data set, make their for their domain, and that's how we can take it forward. But yeah, looking forward for further collaboration and further discussion. That's right.
Yes, sure. So I think we'll discuss more over phone and WhatsApp details regarding the collaboration.
Sure, sure.
Hello, Srinivas. Good to see your face. So handsome face.
Okay, thanks everyone. Thanks Ashish and Jagbandhu for giving me the platform. And good to see you guys, particularly IIT